Algebra 2, Chapter 3.1, exercises 12 through 18. This section has to do with vertex form of quadratic functions, and specifically completing the square. And we're going to have problems in this real-world section of projectile motion, which you will get to in physics. But projectile motion formulas are as follows. We have h of t is equal to negative 16 t squared plus v sub 0, and that's a little subscript 0, t plus h subscript 0. And v sub 0 is what we call our initial velocity, so an object that goes into the air, and h sub 0 is going to be our initial height or elevation. Now, as it so happens, this equation or formula is for units in meters. I said meters, it's units in feet. And that's a standard equation, and similarly we have h of t equals negative 4.9 t squared plus v sub 0 t plus h sub 0. Same equation, but this time with units in meters. Now on Earth, our gravitational field, or the elevation due to the force of a gravitational field, is represented by these two equations. And even though we have variances in the gravitational field all around the Earth due to differences in elevation and irregularity of the shape of the Earth, and from tides, from influences of the moon and sun, still these two equations represent quite accurately projectile motion. So we're going to be using these equations as we go forward. And we're going to do the odd number problems in this set, starting with number 13. A circus juggler on high wire tosses a juggling pin upward with an initial vertical velocity of 24 feet per second. So that's going to be v sub 0 equals 24 feet per second. And from a height of 32 feet. So that's going to be h sub 0 equals 24 feet, or 32 feet. A, how long does it take the pin to reach its maximum height? We'll be able to find that quite easily if we use or have the vertex form of the equation. We're going to start out with a standard form by writing down h of t equals negative 16 t squared plus v sub 0, which is 24, t plus h sub 0, which is 32. And we're going to convert this standard form equation into vertex form, and as follows. We have h of t is going to be equal to negative 16, and then negative 16 times what equals negative 16 t squared? Well, that's going to be t squared. And then what we're going to have to do is factor out a negative 16 from this 24, and to do that, if we take 24 divided by negative 16, we're going to get negative 12/8, which simplifies to negative 3/2. And we're going to subtract then 3 halves times t. I hope you can see that if we multiply, and this is how we can test, if we multiply negative 16 times 3 over 2 times negative 3 over 2, we are going to get 24, meaning that we have effectively factored out negative 16 from this 24t. And next we're going to take this negative 3 over 2 and divide that by 2, and when we get negative 3 over 2 divided by 2, we get negative 3/4. And negative 3/4 is a special number now. We've found that I'm going to asterisk here. And to find out what we need to put in place to complete the square, let me go ahead and finish out here. We're going to have to add a number to complete the square, and on the outside compensate for that number, and finally add the 32 on the outside. And what we do is we take this negative 3/4 and we square negative 3/4 and get negative 3 squared is 9, and in the denominator 4 squared is 16. So we're going to add 9/16. So that's going to complete our square. Now on the outside we have to put a number here that I'm boxing in to compensate for adding that 9/16. And what number do we put there? What we do to find that out is we take this 9/16 and multiply by what we had on the outside, which is negative 16. 16 over 16 cancel, and we get negative 9. So by completing the square and adding 9/16 inside the parentheses, what we are doing to the whole equation on the right side is subtracting 9. Therefore we have to add 9 to compensate for having subtracted effectively 9 on the inside. And now our completing the square is completed as follows. We have negative 16 times quantity t, and let's look back at that number that I asterisked up here, this negative 3/4. So I put minus 3/4, and we're going to square that. And the outside we're going to take 9 plus 32, or 41. So now we have our vertex form from which we can answer the question here. How long does it take the pin to reach its maximum height? It takes 3/4 of a second. And second question, what is that height? That height is 41 feet. That'll be our maximum height. And so those will be our answers to part A. And then part B, the juggler missed the pin on the way down. How long after the pin is tossed does it pass the juggler on the way down? So we can make a little sketch here. And in this sketch, we have the juggler's position at 32 feet above ground, and we have the pin going like this toward the ground, and we reach its vertex, which is the point 3/4, 41. So I had a student in 8th period yesterday, Bryce, who said, how long does it take to pass the juggler on the way down? Well, that's going to be 2 times 3/4 of a second, which equals 1.5 seconds. And question, how do we know that? Well, because of the symmetry of a parabola, because symmetry of parabola that'll dictate to 2 times 3/4 is going to be equal to 3/2. So 0.75 seconds on the way up, 0.75 seconds on the way down. And what I did for this one is, prior to recording the video lesson, I entered this standard form equation in the TI 84C calculator, and if we graph that function, and we're going to see, I'm going to enter y2 equals 32 feet, and so we can answer part B. We push second, trace, 5 for intersection, and we're right close to the intersection. Enter, 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 and we can see we have a height again of 32 feet at x equals 1.5 seconds. And for a maximum, if we put second trace 4 for maximum, and we arrow over here, it says left bound, we arrow here to the left of the vertex and press enter, and then it says right bound, so we arrow over to the right and press enter twice. We get y equals 41 feet, and then x equals 0.75000. That's going to be 15 10 millionths or something like that. So that's going to be our vertex, just as we figured out. Next problem, I want to not work entirely, but 14, we have our negative 4.9 t squared. So it's going to be working out the same as we did for 13, but we got to recognize we have this negative 4.9 to be factored out, which is not as easy to work with as 16, so you'll probably want to use decimals for that. Next ordinal problem we want to actually do is 15, explain the error. 2 attempts to write f(x) equals 2x squared minus 8x in vertex form are shown. Which is correct? Explain the error. And we have attempt A and attempt B. And as we look at attempt A and attempt B, we should see that they are precisely the same for this first line and precisely the same for the second line. It's only on the third line where in attempt A we are subtracting 4, whereas in attempt B we are subtracting 8. So we are asked the question, which is incorrect? Well, in attempt A, what we have is 2, we have 4 to complete the square, but we also multiplied by 2. So we have actually added 2 times 4 or 8, yet on the outside we're only subtracting 4. So this minus 4 does not offset what was added in completing the square, whereas in attempt B we have subtracted 8, which accounts for adding 8. So which is incorrect? A is incorrect. And then we are asked to explain the error. Well, how we explain the error is A fails to account for 2 times 4 when completing the square. So minus 8 is needed. And that is why A is incorrect and attempt B is correct. Okay, let's go on to the next on our problem. which is 17, we have analyzed relationships. The functions f and g are defined by fx equals x squared plus 2x minus 2 and g of x equals quantity x plus 1 squared minus 3. Do f and g represent the same function? Explain. Well, one thing we can do is take this f of g written in standard form and complete the square to see if we get effectively what g of x is. And I had a student yesterday, Steve, in class who did that. But the way I think might be a little easier is to take this g of x equals quantity x plus 1 squared minus 3 and expand that out to see if we end up getting the f of x. And we're first going to expand that quantity x plus 1 squared. And to do that, I'm going to make this little box that I make a 4x4 out of. So we have x plus 1 on the top and x plus 1 on the side. So we get x squared. In the upper right corner we get 1 times x or x. In the left corner we get 1 times x or x. In the lower right corner we get 1 times 1 or 1. And we add these like terms together. We're going to get x squared plus 2x plus 1. So now in g of x we're going to replace quantity x plus 1 squared with x squared plus 2x plus 1. I'm going to parenthesize that just to indicate that it takes care of all that quantity x plus 1 squared. And on the outside we're going to subtract 3. And then removing the parentheses, we're going to end up with x squared plus 2x, and then we have 1 minus 3 or minus 2. And we notice that that is going to equal f of x. So we say, yes, they are the same function. I'll put the same function. And then we are asked to explain. Okay, that's a pretty easy explanation. Expanding and simplifying. Put expanding and simplifying. G of x gives us f of x. And you can check using a calculator also, but that's going to be it. Now, the exercise set says 12 through 18, but we're going to go do our final problem in this video lesson performance task, which we have a real-world volleyball playing problem. We have a player bumping a volleyball from a height of 4 feet. So that's going to be our h sub 0 equaling 4. And then with initial velocity of 20 feet per second, so that's going to be v sub 0 is equal to 20. So that's going to give us a function standard form of h of t is equal to negative 16 t squared plus 20t plus h sub 0, which is 4. And so now we're going to complete the square with this to be able to find the maximum height of the ball. So I'm going to write h of t is equal to negative 16, and we have t squared. And so now we ask ourselves a question: what do we factor out of 20 to make it such that when we multiply by negative 16 we end up with 20t? Well, to find that, what we do is I'm going to work this up here in the upper right. If we take 20 and divide that by negative 16, we're going to get negative 5/4. And so minus 5/4 t is what's going to go here. And then we're going to add something to complete the square, and then account for adding to complete the square on the outside, and finally we're going to add 4 on the outside. Now we're going to take this 5/4, this negative 5/4, and divide it by 2, and what we get for that is negative 5/8. And negative 5/8, I'm going to asterisk negative 5/8, just like I did for problem 13. And then we're going to take this negative 5/8 and square it to result in negative 5 squared is 25. And in the denominator, 8 squared is 64. So we're going to add 25/64. And we've added 25/64. What do we have to subtract? We're going to have to subtract, well, if we take negative 16, which is on the outside of the parentheses, times 25/64, negative 16 over 64 simplifies to 1/4, so we're going to get negative 25/4. So effectively, by putting 25/64 on the inside, we are subtracting 25/4, meaning that we're going to have to add 25/4 on the outside to compensate. And rewriting h in vertex form, h of t in vertex form, we're going to have h of t is equal to negative 16 times quantity t minus what we put in asterisks here, minus 5/8. And then we're going to have squared plus, what we have is, I'm going to write in the lower right here, we have 25/4 plus 4, and 4 is 16/4, getting our common denominator, which equals 41/4. And 41/4 in decimal form is 10.25. So that's what we're going to put out here, plus 10.25. So what is the maximum height of the ball? It's going to be 10.25 feet. Okay, and finally, in part D, suppose the volleyball were hit under the same conditions but with initial velocity of 32 feet per second. How much higher would the ball go? So for this one, if we take h of t is equal to negative 16 t squared plus 32 t plus 4, let's convert that to vertex form. We have h of t is equal to negative 16, and we factored out from t squared. And what do we put next? Well, we have 32 times negative 16, which is negative 2. So we're going to place minus 2t, and then negative 2 divided by 2 is equal to negative 1. So that's our special asterisk number right there. And then negative 1 squared is equal to 1. Meaning that plus 1 is what goes outside here. And then what we've done is we subtracted negative 16 times 1, so we're going to have to add 16 plus 4, and completing the square we get h of t is equal to negative 16. We're going to have quantity t minus 1 We're going to square that, and then we take 16 plus 4, which is 20. So plus 20. So now we're ready to answer. How much higher would the ball be? The ball would be 20 minus 10.25 equals 9.75 feet higher. So there we have it. I hope this has been helpful to you. Good luck, and thanks for viewing.